Sure. Hi, everyone. I am Nicole Gugliucci. I've had a really great time so far chatting with everyone here. I am an associate professor of physics at St. Anselm College, which is a tiny little liberal arts college in New Hampshire. I am going to be talking to you a little bit about my work with citizen science, how we look at how communication is done within citizen science projects, what motivation is important for citizen scientists, and connecting that to the Radio JOVE Project. So a little of my background, I pulled out some old pictures of me. The top left, 20 years ago this fall, was my first time using the Green Bank telescope when I was a baby grad student. As I've talked to a bunch of people here, I love this site. I spent a lot of time here when I was a grad student at UVA. Did some stuff on the GBT, but primarily I worked on an instrumentation project with Rich Bradley in our area of Charlottesville. So there is also me from 20 years ago trying to hook cables together for our correlator out of the site. And I had wanted to be an astronomer since I saw the movie Contact, right? So I saw the movie Contact in theaters as a teenager, and I wanted to be a radio astronomer. And you know, I took all the physics classes, took all the astronomy classes, took all the math classes, did a PhD doing a radio astronomy project, and then realized what I really liked doing was the education and outreach side. So I switched gears. Crazy thing when you get a PhD, you can actually do something else. And you can actually switch gears from doing radio instrumentation. So the bottom left is a group of teachers that I was working with. For my postdoc, I worked for a citizen science project called CosmoQuest. It was a primarily a crater mapping project using data from the Moon, Mercury, and Vesta, because computer algorithms still get tripped up on pictures of craters and getting the measurements in right. And so having citizen scientists work with that data, work with those images, gets us professional level results, and much better than we could do an automated algorithm. So I was the informal education lead of that project, doing a lot of the communications. We did teacher workshops, so this came up earlier. Yes, you have to pay teachers and give them continuing education credits. But you design a curriculum, you show them the curriculum. That was, I think, a 4-day workshop. It was a 4-day workshop. And they start implementing it, and it's really fun. After that, I went to St. Anselm College. So my job primarily is as a teacher. I teach physics, astronomy, and now math classes because the math department is understaffed. But in 2019, I got a Radio JOVE kit and for an after-school program that's run at my college called Access Academy. They pull together students from Manchester High School, particularly immigrant, refugee, and low-income students. And they come to campus and they do some type of they get a little bit of high school credit for it, but they do some type of course and some interesting topic that's hands-on, taught by college students. So I had 4 college students working for me. None of them had done radio astronomy before. None of them had done any astronomy before. So they learned on the fly a little bit about astronomy, radio astronomy, and how to build a radio JOVE. And then they broke these high school kids up into build teams, and each built a part of it, set it up, did the data analysis, did all that fun stuff. So we now have a Radio JOVE 2.0, it's not 2.1, on campus, and so I have undergrads who've been working on developing that. It was about a year ago, I think, I gathered up all my courage and emailed Chuck, who didn't know me from a hole in the wall, saying, "Hi, could I work with you guys?" And because Chuck's awesome, he said, "Sure." Because I'm particularly interested in the citizen science aspects of the Radio JOVE Project and how we can make this the best experience for as many people as possible. So here's the definition I pulled. This was actually added to the Oxford English Dictionary in June 2015. It's about when I started my job as a professor. And that being the collection and analysis of data relating to the natural world by members of the general public, particularly as part of a collaborative project with professional scientists. This is a very broad definition. There's a lot of things that fall into this category of citizen scientist, or it's also called participatory science, and there's lots of other ways of talking about it. But there's an entire community of educators and scientists who are working specifically on how do we make the citizen science experience the best experience possible. So some of, if you've never explored the website SciStarters, anybody played around on SciStarters before?
SciStarters.
A couple of people, great. Oh, wait, sorry. Forgot. I'm trying to do my notes on screen. SciStarter is a website that lists tons and tons of citizen science projects. Everything from, there's the low buy-in stuff like CosmoQuest that I worked on. All you had to do was go to a webpage, do a little tutorial, start marking images, right? That had, kind of a lower on-ramp to get started. To things like Radio JOVE, where you actually buy and build the instrumentation. Turns out, a lot of the work in this space is being done around ecology, because people, citizens, everyday people are interested in the ecology of their own local location, and can contribute much more than the professional scientists who are out there trying to do field work. So after working in radio astronomy and then working in citizen science, I finally get to bring this together. I consider Gro Reber to be the original, my favorite citizen scientist. I pulled this quote from Ken Kellogren's obituary in 2003, where he said, "So, as he lived, I consulted with myself and decided to build a dish." I consulted with myself. I love it. We see, and so somebody like Gro Reber and somebody like everyone here in this room, you're probably the folks that I don't need to motivate. I don't need to tell you how awesome radio astronomy is, and get you excited about doing that project. We have that community here. What we want to do, of course, is expand that a little bit and get more folks interested at different levels. And me particularly is interested in getting educators involved. Because as we, again, talked about before, if you get teachers interested in the project, then they are going to see, I don't know what typical classroom sizes are in high schools anymore, but 20, 30 students a year, and be able to pass that on. Some of the, so I do not have a background in solar radio astronomy. All my stuff was extragalactic. Yeah, think extragalactic. Although I did a little bit of the ionosphere. So I'm not as, actually the next talk will be a little bit about some of the science that we're going to be trying to do. But I wanted to give you an example from the project that I worked with as a postdoc. I mentioned the crater mapping project, where this was actually studied to show that the contributions of citizen scientists could meet and surpass the contributions of an expert scientist. So at the top, Stuart Robbins is a planetary scientist. He had some of his colleagues mark up images of the moon. Stuart has a permanent, not scar, but bump on his finger from where he was marking craters, millions of craters by hand with a stylus as a graduate student. This is how these maps are made and how these crater statistics are done by hand. So obviously it takes a very long time. And so we had a number of collaborators who were professional planetary scientists mark those craters, and you can see, the differences here, the different colors with the different individual scientists. And then we compared that with the contributions of citizen scientists, and that's this bottom one on the left here. So you see a lot more classifications. You have kind of a difference in classification. So you have, my students, I'll take them to a project on Zooniverse like this. And every year they say to me, well, what if I mess it up? I'm gonna mess up science. As you can see here, some folks, maybe when they're new, they're circling the shadow of the crater, not the whole crater themselves. But by and large, when you average over all of those contributions, you get the same, just they get a matching distribution and in way less time. And in a way that has involved all of these people in the science along the way. So that's what I'm hoping, we can get to that next step with Radio JOVE. We look at our science and can actually contribute where there's limited resources in the professional field. So, the way I'm thinking about this, the way I'm looking at this, this is from a PhD thesis, 2015, all about online citizen science projects. We are not quite an online project because you have to build a thing. But this is one of Dr. Curtis's models that came out of this dissertation. There's tons and tons of research on the actual sociology of what's happening in a citizen science project, right? So you have a project task. What's the person's motivation for doing that task? How is their interaction? There's tons of letters that go to other figures. How do they interact with that task? What contribution do they make? What contribution do they feel they're making? It's a lot more complicated than just putting it on a website and saying, hey, come do science with us, to keep that sustained interaction. And you can also see this is what I was mentioning earlier, there's a range of projects. So she looked at a huge range of projects, some that were lightweight, right? This is one where you go to a website, you don't have to sign up. You just, you can kind of show up and do some classifications and then move on with your life. A lot of citizen science is done by folks who check it out once or twice and never come back. All the way to heavyweight or more community-based, which Radio JOVE is more in that category, because we're asking you to buy something, build something, and do a sustained project. But there's that high threshold of participation that makes that a little bit harder. So we're looking at some ways of introducing some kind of lightweight tasks, because we have all this archived data and building an image repositories that new people could come and look at the images and identify Jovian and Solarverse by eye and start to learn about it that way and give them an easy on-ramp to, oh, hey, you can actually build this yourself. I was particularly interested when I was working with CosmoQuest on who our citizen scientists were, why they were working with us, or why they weren't working with us at all. And so we interviewed 30 of our participants. We interviewed 30 participants for research projects, and we had all kinds of reasons and motivations. There's a huge body of literature on just on people's motivations. Whether they did it because they liked science as a kid and wanted to contribute now that they're adult, whether folks that were students who were doing it for a school project, all kinds of different motivations. We looked at how many of those people had motivators that were primarily intrinsic. I do this because I like it. I do this because it feels good. I do it because it's fun, which is kind of our blue, our intrinsic motivators. And then how many people were doing it for an extrinsic motivator? I want my contribution to science to count, or I needed to do this for a school project. I think we had maybe one of those. I had to throw out an interview that was of somebody because they told us at the end of the interview they were under 18, and we're like, crap, our IRB is only for 18 and above. And what we saw is that based on the frequency of participation, this was some language we had we adopted from a similar study. There were some folks who were dabblers. They would come and do it every once in a while, and then maybe not touch it for 6 months, and then maybe come back and try again later. We had persisters. Those are the folks that logged in regularly to do classifications, maybe once a week, maybe a few times a week. And there's a difference in what motivations they gave us as their primary motivation based on their pattern usage. So this is really important for Radio JOVE because this is a very different pattern usage, right? You have to build it, you have to maintain it, we have to keep it going. And so we need to, that tells us we need to look at those intrinsic motivations and see how we can highlight that for folks. And find the folks that are interested in doing the science for the fun of it. We also were fortunate, we had a couple of our users who had started with the project and then had quit and they weren't doing it anymore. But they were still involved in the, there's like a social, there's a social forum, and we did a whole bunch of, we made a ton of video content. We did lots of weekly chat shows. But we had a couple of folks who stuck around for the social stuff, but weren't doing the science anymore. And we asked them why. Why did you stop? And we got kind of a good range of reasons. There's a lot of factors that can't be controlled. One's like, I had a baby. I got a different job. I graduated. You know, a lot of people, the main reason that they stopped was something internal to them. But there were a handful of reasons where people gave reasons like, well, there wasn't enough communication from the science team about what we're doing. So I felt like I didn't know what I was doing it for. Or I was having technical issues with the browser and couldn't get past it, couldn't figure out how to fix it. So we found some of these ways of communication and feedback and technical issues being really key to keeping someone's interest and keeping them coming back. And so that's something I look at when we talk about designing citizen science projects is how am I'm not just putting the information out there, how am I making the information the most accessible? And how is the community reacting around those results? There was a recent paper about citizen science that I wanted to highlight. This was in, I think, ecology. Oh, it was in bioscience. And it really looked at citizen science from the perspective of the participant. Much of it usually talks about the science itself, not about the people doing it. This paper said, citizen science is personal, participation is contingent on the citizen's connection to a topic or interpersonal relationships that are meaningful to them. But from the peer-reviewed literature, scientists appear to have an acquisitive, data-centered relationship with citizens. And so this is something that they were showing as a warning. This is spurring ethical and pragmatic criticisms of extractive relationships with citizen science. And so this was kind of a call to the citizen science community of like, hey, you know, when you're building a citizen science project, you got to make sure that there's a two-way street. It's not just give me your data and then you take the data and you go do something with it. That there is more. One of the main reasons for having citizen science in the first place is to break down those barriers between, say, the ivory tower science and the fact that all of us know that science is an integral part of our lives. So this is something that I'm considering as well. Citizen science projects are relational. The quality of the data improves with reciprocity. So not only do you want to take that into account when you're working on a citizen science project, you know, just because you want to have that relationship with folks, the quality of the data actually improves when the community gets something out of it. And I think, you know, again, all of you are here because you're jazzed about it and you love it and you get a lot out of it. So that's probably like a no-brainer for us. But this is something to consider when we're having these conversations about how to grow the community, how to connect with students, how to connect with younger folks, is to think about the reciprocity of the relationship that we want to build. So my work this summer, as I finally finished grading this is my first year as department chair, so it was a lot. So I get to actually work on this summer. So I'm going to be starting. I'm hitting the wrong button again. Here, I'm going to be starting. We're doing a design-based research project, basically. So my research it's part research, but it's also part practical. How can we design the citizen science resources for Radio JOVE to be the most useful? And so I'm going to be looking at educational theories. I'm going to be looking at citizen science research. I'm gonna be looking at learning theory, because I do, again, do tend to focus, on educators and students, as well as just folks who are interested. And I'll be going through this process in helping us build our citizen science projects, as we go. So over here, of course, this is, Solarverse, this is what we're gonna be talking about, what, who's going next, is it Dave? Yeah, Dave will be talking about the specific science we're looking at. But I'm gonna be keeping in mind, how do we get folks there to that point of doing that science? And what are folks gonna get out of it? And how are we, and this is something, again, I think we've been talking about as community too, how are we gonna reach more folks with it? From across a wide spectrum. So, yeah, that's it, and my contact info. And I put this talk and a whole bunch of other stuff about our St. A's, Radio JOVE, and some of the student projects that I've had up at that website, so you can check that out as well. Thank you very much.
Time for a question? Any questions in the room? Any questions online?
How do you sort of, when you're getting data from people, you're gonna get occasional things that are nonsense, because like watching the radio astronomy, groups.io thing.
Yeah.
Once in a while, I see somebody starting out and they get some kind of interference. They just know they've discovered something absolutely fantastic, and somebody has to break it to them. No, you got the RFI from a bad cover on a oil heater furnace or something, you know?
Right.
How do you handle that, if, occasionally getting data that's really
Yeah.
totally out of whack?
Yeah, and that comes down to having the two-way communication already set up to begin with, right? And having those relationships to begin with. Being able to have a conversation about, about data and about results, but not just make it about that, kind of like, I'm thinking how I would approach that. I think of it as like the sandwich thing, right? You've got a criticism, but you can sandwich it in like, here's some stuff you're doing really well, and here's some stuff you're doing really well. Here's where I think we may need to do some work or rethink it. It's the kind of stuff I, just in the classroom all the time. I'm like, yes, that's a great idea. It's wrong, but it's great. I want to encourage the process of thinking there, even if the answer itself isn't wrong.
So the whole thing is just not make somebody feel bad about getting bad data,
Right.
rather encourage them to
Yeah.
improve.
Yeah,
Yeah.
right, encourage,
Okay.
and I always share my failure stories with my students, especially when it comes to data analysis, because they come across things and they'll work for a whole week on something and it turns out to be a bust. So I also share that vulnerability, as well. It's like, here's the time I thought I saw something, but with more analysis I saw that it was something, RFI.
Do you see much, she brought up like classification of graders and things like that. Do you see a lot of citizen science projects that are migrating more towards the classification algorithms, machine learning? Because human in the loop of categorizing things is, I haven't seen it being done.
Mhm.
And so I didn't know if you see citizen projects kind of migrating more towards using the tools of machine learning.
So what I've seen, Zooniverse is a platform that hosts a huge amount of citizen science projects. A lot of them are of this classification base. What we saw with the crater studies, it was a separate project where they did have algorithms working on it, is that humans were really helpful in the edge cases. This is also, this is actually also behind the Pulsar Science Collaboratory. I don't know if folks have heard about that, or probably talked about that here. Having, the algorithms are searching for those pulses in that data, but there are a lot of edge cases that the algorithm can't quite figure out. And that's where the citizen scientist comes in. So I've seen a lot of movement towards that. Also, there are a lot of small projects where it's data from this one particular instrument, from this one particular period of time. The time it would take to create a machine learning algorithm to look at it, right? The amount of effort that would go into that for that one-off project doesn't seem worth it. When you can put together a citizen science project, and people are going to get that much faster. and be able to work with that. So yeah.
Thanks.